Hello everyone, welcome back to another class on hydrostatic force, and for today we will continue with the study of hydrostatic force on curved surface. Okay, in order for us to calculate the hydrostatic force in curved surface, first we need to remember how to calculate the hydrostatic force in flat plane, which is for flat plane we have three different calculations, which is tilted plate, vertical plate, and also horizontal plate. Okay, for the curved surface we will involve these two calculations over here. Okay, given that we have a wall and the wall is connected to a gate that looks like this, and the gate is connected to the floor of a tank or a reservoir. Okay, and assuming we have liquid over here at a density of F. Okay, so the first thing that you need to know is when we deal with curved surface, the curved surface is seen from the side view, which means that we're seeing this from the side view, not from the top view. So this gate over here is an example of a curved surface. Okay, in order to continue with this, the first thing that you need to know is for every curved surface, we need to bring out a volume from the system. Okay, the volume is found by having vertical line and horizontal line drawn from the curve. Okay, so this part over here will be the volume for the system. Okay, so the volume should be looking like this if you bring it out. Okay, and from the volume we need to show the forces acting towards it. Okay, the forces acting towards the volume will be Fy, Fx, and also W. Okay, so in order for us to have the x direction force, y direction force, and also the resultant force, we will have to draw an Fr over here acting towards the body straight from the center of circle. Okay, and here we'll have the component of Fv and the component of Fh. For your understanding, the Fr should come from the inside of the volume because the study that we are doing right now is hydrostatic. However, we draw the Fr, Fv, and Fh over here in order for us to simplify the visual of this picture, because if you put the Fr inside the Fh and Fv, we will have multiple force acting inside the same place and will be quite confusing. So usually we will mirror the Fr, Fv, and Fh to the other side of the curve. Okay, so based on this, we will have two different part of calculation. Calculation number 1 is based on summation of Fx equals to 0. So if you see, these two are the components for Fx. Okay, it is Fx minus Fh equals to 0. So the Fh or F horizontal is equal to Fx. In order for us to calculate Fh or Fx, first what you need to do is we should draw a picture. Okay, that is represented as a rectangular plate. Okay, the picture actually comes from this line over here. We assume that this is a rectangular plate and it is having a distance of S from the surface with a 90-degree angle. So the Fx should be acting here through the center of pressure. This is the center of gravity. Okay, so as we learn in our study of flat plate, This is called as a vertical plate calculation. Okay, first we need to find out what is YC. YC is actually equal to S plus B over 2. Once again, this is B over 2 because we are dealing with vertical plate. Right? And to find out FR, FR is equal to rho G YC sine 90 degree A. And because this is a rectangular shape, the A vertical plate rectangular, A is equal to A times B. Okay, so the A is the width, B over here can be considered to be the radius. Okay, so why do we call it radius? Because from this picture over here, usually the picture that we have is a partial of a circle. Okay, and this gate over here can be considered as a quarter circle or quarter cylinder. Meaning, if you have a quarter cylinder, for example, this picture over here, I draw it back over here. This is a quarter cylinder. This is 90 degree. We can assume this as radius and also this as radius. So this radius over here is also equal to B if you are doing it in vertical plate calculation. Okay, so the S is from the tip of the plate to the surface of the liquid. Okay, so if you do the calculation correctly, the FR should equal the FH. Next, we will do a calculation on summation of F in terms of Y direction equals to 0. Okay, so we have three components over here, W and also Fy. Okay, so this is based on the volume that we have. So the direction of flow, you must remember Fx will always act towards the vertical line and Fy will always act towards the horizontal line. This line will give you a direction on where the force will be acting on, and W will always acting downwards because it is following the gravitational acceleration. So this line over here is a horizontal representation and this is a vertical representation of the volume. So if you do summation of F in the Y direction equals to 0, it should equal to, for example, for this one, negative Fy minus W plus Fv equals to 0. So Fv or F vertical is equal to Fy plus W. Okay, so we have two components over here, Fy and also W. We will have to solve one by one. For Fy, in order for us to do this calculation, we will use a horizontal plate calculation. Okay, so we have to assume that this is also a rectangular representation. Okay, and this should be a representation for this part over here. Okay, and the distance from the top or the surface to the surface of the plate should be equal to Hc. To find out Fy, Fy is equal to rho G HCA, and once again the A is equal to A times B. Okay, and the B once again is a radius, the A is the width or the length. Okay, so the next part is W. For W, the equation is equal to rho times G times V, which is the volume of the plate. The volume of the liquid inside this shape. Okay, so to find out the volume, it depends on the shape of our volume from the picture over here. So because the picture that we have over here looks like a quarter circle, so the volume should be pi r square over 4, pi r square is the area for the whole circle, and you divide it by 4 to get a quarter circle, and then multiply it with a, which is the width or the length of the gate. Okay, so whenever I'm talking about a, it means the length of the gate to the back, like this. Okay, this length can be a. Sometimes they use L for the denotation. Okay, so W should equal to rho times G times pi r square over 4 a. This is due to the quarter circle shape of the liquid, or for this case the volume should be a quarter cylinder. When we get the answer, so we can combine Fv to be equal to rho g HCA plus rho g pi r square over 4 multiplied by a. So when we are done with this, we have to find out Fr, and Fr is just equal to Fh square plus Fv square, and then square root of that should be the answer for Fr. And another one, we call it as angle of the direction, or angle of application. Okay, so for this one, we use tan theta is equal to Fv over Fh. So theta is equal to inverse tan Fv over Fh. Alright, so what does the theta represent? So the theta will represent, for example, this is the volume that we have just now. The theta will represent the angle between Fr and also Fh. Okay, so in case we want to show it in terms of the actual condition of hydrostatic force, we can mirror it back to the other side. So the Fr and Fh should look like this. Okay, this is Fr, okay, and this is Fh, and this is the angle theta. Okay, so that will be the explanation on hydrostatic force in curved surface. To continue with hydrostatic force in curved surface, there is time where the surface or the volume of the fluid will be different and not a quarter circle. Okay, so we want to know how to do things when the design of the volume is not a quarter circle. So for example, if you have a picture like this, this is the gate, and this is the fluid rho F. Okay, so if you need to draw the volume, instead of a quarter circle, the volume for this particular picture, if you draw the vertical line or vertical representation and the horizontal line, you will see that the volume will look like this. Okay, so the volume is different than the volume that we have before, but we can still put Fr, Fv, Fh, W will be downward, Fx and Fy. So remember, your F should be acting towards the volume and the W should be acting downward because we are following the gravitational effect. Okay, so if this volume is here, there will be a change in two parts, which is the first part, the change that we will have is in terms of summation of Fy equals to 0. Fy is sensitive towards the shape of the volume. For example, right now, if you can see, the Fy over here is at the bottom part of the curve. Okay, so if you do Fy, okay, and W will be different compared to the one that we did before. So based on this volume, you can see that the Fy is acting upward for this question, and minus W minus Fv equals to 0. So Fv is equal to Fy minus W, and this is different compared to the picture that we have before, because the picture that we have before this is Fy plus W. It means that whenever the volume is different, there might be a possibility of Fv to be having Fy minus W or Fy plus W. So it all depends on the shape of the volume and the direction of force acting towards it. The second part that we will have a change is in terms of W. W is equal to rho times G times V, but the volume for this picture looks like this. We can never use pi r square over 4 again. So how do we calculate this volume? It is calculated through this idea. Assuming we have a square, which is r, and r, the area should be r square, radius square, minus a quarter circle that looks like this, okay, where this is r and this is r, and the quarter circle is pi r square over 4. These two will create this volume that we see over here, meaning this part is r, this part is also r. So actually this volume comes from a square minus a quarter circle, then you will get this shape. Okay, so to find out the volume, V is equal to r square minus pi r square over 4 multiplied by the width or the length of the study. Okay, so this is different than what we have before. Other than that, all the other calculation should be the same without any other changes happening inside it. Only these two parts, which is summation of Fy, because the shape of the volume is different and the force acting towards it is in different direction. And number 2 is when we deal with the volume. So the volume should be different here, because this is no longer a quarter circle. This is a square minus a quarter circle. So it is really important to check on the volume and to draw the right volume from the picture. The volume must be drawn from the inside of the liquid. Okay, I think that covers the theoretical part of this study.